and that line looks a little bit positive. It's got a positive intercept, not intercept, sorry, positive estimate. But that's fine. So just imagine it like this: that somebody who has statins, their rate of decline is going to be less than somebody who is not on statin. Kind of something like this, you know. So can you make the case based on that answer? And the answer is no. I'm not gonna take any points off, you know, if you say yes. But the answer is no, because it is a survey. It's a point in time. It's just done. It's not longitudinal. It's a cross-sectional study. It's a single point in time, and so if you know, you can have that conclusion that older individuals tend to have lower RFFT scores, but you cannot say when it started declining or if it's declining with age. You don't know. For all you know, it's a point in time. So for all you know, from here on out, they're actually gonna be increasing, and it might look like this. Excuse me. My allergies are working up, and so the answer is no. You need to have some sort of a longitudinal study. You might need to have some sort of a cohort study that goes on for some time. And then we can get into the issues of the Simpson's paradox and stuff like that, but that's for more advanced biostatistics. Okay, so for 7.4, they're asking us to write out the equation. And that equation looks a little bit like this. The estimated eggs equals negative 18.82, which is the intercept, plus 1.77 Wolbachia, having it or not, and 0.357 tibia. All right, and that's the answer for A. For B, the intercept does not have a meaningful interpretation, represents the expected egg count for a wasp with tibia length of 0 and no Wolbachia. So you're not going to have negative eggs, right? So you can do several things, and this is again advanced biostatistics, so you can offset your values to set her at 0. That's fine. So each 1 unit increase in tibia length is associated with 0.357 eggs on average, and each 1 unit increase in Wolbachia density is associated with 1.77 eggs on average. And then finally C, it goes a little bit like this, negative 18.82, right, plus 1.77 with the Wolbachia value of 3.435 negative, plus 0.357 times 171.4286. And the answer for all of this is about 36 eggs. From 7.10b, the line is something like this: minus 57.99 plus 0.34 times 79 plus 4.71 times 11.3, which is about 22.1, which is less than 24.2. So the model underestimates the volume of the 3 by about 2 cubic feet. Okay, and this one for B, it is 1.46 plus 1.09, which is equal to 2.55. And C, the estimated intercept value is a predicted mean poverty ratio for an individual who had most completed 8th grade. Right, remember the intercept is just putting zeros on everything but the first number. All right, and that will be the mean of whatever you're trying to get. So somebody who didn't go to high school, somebody who didn't go to college, and somebody who is not a college graduate, you know, is at least at eighth grade. So that cancels everything out to the right of 1.46. All right, 7.20a, serum is equal to 97.77 minus 3.02 age, minus 16.28 male, plus the interaction term 2.94 age times male. And if you notice a pattern here is that I want you to be able to, big hint for the final exam, I want you to be able to read these things, right? What does the intercept mean in this context? What does the interaction term mean in this context? What if the interaction term had a p-value greater than 0.05? All right. So for 7.24, here is learner status. That should be removed. Why? It has the highest p-value. It has the highest p-value, and its removal results in an adjusted r-squared that is higher than the current adjusted r-squared. Okay? So remember, when you remove something, what does it do to the r-squared? Does it explain more or less? And you want it to explain more when you remove or add something. The last one, 7.28a, the F statistic, The F statistic for the model corresponds to a test of the null hypothesis that the beta for each slope equals 0. Okay? The null hypothesis here is that the beta for each, however many betas you have, all equal to 0. And the alternative, just a little more info for you, the alternative is that at least one of them does not equal 0. Okay? At least one beta does not equal 0. And, I'm sorry, not B, C. Under the null hypothesis that the 6 slope coefficients are all zeros, all 6 resilient groups would have the same mean difference in BDI score. This is the same as a null hypothesis for an ANOVA with 6 groups. And the ANOVA for the 6 groups, remember, would be that the mean of group 1 equals a mu of group 2, which is a mu of group 3, which is a mu of group 4, and 5, and 6, which states that all 6 population means are the same. Okay, remember sample means, population means. So the null here is that all of them, if we do an ANOVA, would be like that, and here we're doing it with multiple linear regression. Okay, and with that is it. If you have any questions, comments, concerns, you know where to find me. Post it on the discussion board, send me emails. I'm planning on doing a final exam prep soon, so look for that soon. Other than that, thank you and have a good rest of your week.